So we have seen what exactly is this thermal properties of matter. We have seen how the heat transfer takes place. Then we saw the modes of the heat transfer. Also we have seen some of the laws that are based on the heat transfers, like the Kirchhoff's law, the Stephen-Boltzmann law, and the Wien's displacement law. Now we are going to use all these concepts that we have studied and the experience gained from solving the questions in solving some of the previous year IIT-JEE questions. I have collected some of the best questions that were asked in the previous year IIT-JEE. So let's try to solve these questions. Let's solve some of the previous year IIT-JEE questions and see how we can apply the concepts that we have studied in solving these IIT-JEE questions. Now, this is a block of ice which is at minus 10 degrees Celsius, is slowly heated and converted to steam at 100 degrees Celsius. Now, which of the following curves it represents phenomenon qualitatively? What it asks is that you have to see which of them explains it qualitatively. So you are not bothered about the length of this or the slope of this, rather the nature which follows the situation given above. Now the situation says that you have ice. This is at minus 10 degrees Celsius. You have to finally reach to water at 100 degrees Celsius. Oh sorry, this is steam at 100 degrees Celsius. So now this is totally air. So this is totally air. So what we have here is we have converted this to steam. What are the stages in which it will go? First it will go to 0 degrees Celsius ice. From here it goes to water. This is again still 0 degrees Celsius. Then it goes to 100 degrees Celsius. Water. It is still water, but now it is at 100 degrees Celsius. And then it goes from 100 degrees Celsius to 100 degrees Celsius, but there is a change of state to vapor. Right? Now, if you look at the figure, first there is increase in temperature. So initially here there is no increase, there is a constant. This is constant initially, so these two are wrong. So these two are the potential candidates. Now among these two, if you see, here it increases, here also it is increasing. Now from here to here, the temperature is a constant if you see, but the heat is being absorbed continuously. And where is it going? It is going in changing the state of the substance. So that means the temperature should remain constant for the next some time interval, this t. If you see in this here, the temperature is suddenly rising. So this is not the correct figure. This here the temperature remains constant. Then it again increases and then again remains constant. This constant is again for this period t dash maybe. Okay. So the correct answer, if you look from this, is A. So you can see if you can simply convert your knowledge of how this change of state is happening, you can solve this question. Now the plots of intensity versus wavelength for 3 black bodies. These are 3 black bodies. Means they have the same emissivity, absorptivity, everything is same. And you can apply the Wien's law here. Different temperatures are given. You have to find out the relation between their temperatures. Now if you look at it in the figure, the way to solve is through Wien's displacement law. This gives you the relation between the wavelength lambda and the temperature. This is the intensity part where the intensity is reaching maximum. Now what is this Wien's displacement law? If you remember, this is a constant, and this which is equal to B, which is called the Wien's constant. Now what is this lambda m? This lambda m is the wavelength at which the intensity is maximum. It's not the maximum wavelength. It's the wavelength at which the intensity is maximum. So if I ask what is the wavelength lambda m in these 3 figures, for this maximum intensity is this. For the T1 curve, it happens here. So that means the lambda m will be this. Let me denote this by lambda m1. Okay. Similarly for this, This is lambda m3. This is lambda m2. Okay, these are the three. These are the maxima points for here. The maxima is here. Now the Wien's displacement law says that lambda m1 t1, lambda m2 t2, lambda m3 t3. These three are equal. This is the Wien's law, right? Now if you look at the figure, what you have here is that lambda m1, it is less than lambda m3, it is less than lambda m2. So this is the second equation that you have, this is the first equation that you have, and you have to find out the relation between the temperature. So we look at the figure, multiplying this with T1, this one with T2 and this one with T3, this relation, it becomes equality. This inequality becomes equality. What that means, since this was the smallest, this must be the highest one. This is the intermediate, this must be the intermediate one. This was the largest, this must be the smallest one, because all are going to get equal. So the T1, so this should be the correct relationship, right? So that this goes to this from the Wien's law. So if you look at the question in the options, the correct option is T1 greater than T2 greater than T2 is the B option. So this one is the correct option. Okay, now this question, if you see there are three rods, they are made of the same material and having the same cross section. They have been joined as shown in the figure. They are joined like this. Each rod is of the same length, okay, and the same material, same thermal conductivity K. Okay, the left and the right ends are kept at 0. This is at 0. These two are at 90. Okay, the temperature of the junction will be, so it is asking us that what is the temperature of this point when this is the scenario. Now if you see, let us assume that this is at a temperature T. Now we know how to solve this question. What we have to do is we have to use the analogy with the electric current. The only difference between the electric current and thermal current is in the terms of their charge, the carriers. In one there is charge, the other one there is the molecules that carry the heat, that transfers the heat. One the energy is flowing through the movement of the molecules. It could be, it is oscillation here, and another one there is a flow of electrons. Barring these, the rest of the things are exactly similar. You can apply all the laws of the Kirchhoff's to this one in the case of thermal current. Now what is the resistance of each of the rods? L by K into A. Now if you see, it's given that they have the same cross section, all the three rods, that means A is same. They are made of the same material, that means K is same. And they are of the same length, that means L is same. What that means, that all the three rods, they have the same resistance R. And this is thermal resistance. Okay. Now, so if you apply the law of current, as I said, you can apply all the laws that are pertaining to current. Let us denote this by I1, this is I2. This is the current. Now whenever I say current here, I mean thermal current. Okay, so, and let me make this I. So I1 plus I2, because whatever the current is coming to a place, it must, their sum must be equal to the current that is going out from that place. That's the junction rule. So we are applying this. And what is the current? I, we know that this is delta T by R. Delta T is the temperature difference. So what is I1? I1 will be, what is the temperature difference for this? This is 90, this is T. 90 minus T by R. Okay. Now what is I2? I2 is 90 minus T by R. Okay, this is current I1, this is current I2. Okay, both have the same value, right? Because it's 90 and this junction is same. What is current I? If you apply the same analogy, what is the temperature difference here? It is T minus 0 by R. Now if you put these three values here, what we have is this. Right? Solving this. Right? Now this RR gets cancelled. This implies which gives us 3T is 180. That means T is 60 degree. Right? So that means the temperature of this junction is 60 degree. So you can apply the rules of the electric current here and try to solve these types of questions that come. You can use if you are able to convert the voltage law, then you can even use the loop rule to these situations. Now here if you see, the emissivity of the bodies X and Y are Ex and Ey, and the absorptive powers are Ax and Ay. Then we have to find out which of these options are correct. Now we have studied a law called Kirchhoff's law, right? The Kirchhoff's law gave us that the emissivity is equal to the absorptive power, right? Emissivity was equal to the absorptive power. Questions asked us about emissivity and absorptive power. So that means according to the Kirchhoff's law, these two will follow the same nature. So now what we have to find out, if we can find the relation of one, we can simply tell the other. So we have to find out the relation between emissivity. Now how to find out this from this graph? Let's mark on the graphs. This is this point. This is this point. This is this point. Okay. Now this is the time scale. Let's make this T1, make this T2. This is T1, suppose this is T2, this is T2 dash. Now this is X, this is body Y. Now in the same time T2 minus T1, this is the time. In this same time T2 minus T1, the body X, it goes this temperature change, right? And in the same time the body Y goes this temperature change. That means the change in temperature of Y is greater than the change in temperature of X, right? What that means, that in the same time Y has reduced its temperature greater than that of X. That means the Y has lost more heat energy than X. How can that happen? If the Y is losing more heat, that means its emissivity is greater, provided that all of the other factors, so their dimensions are constant, which we have to assume, since it's not given here. You have to assume that their dimensions are same. That means Ey will be greater than Ex. Now by the simple Kirchhoff's law application, we know that absorptive powers will follow the same rule, right? Now the absorptive powers here are Ay, Ax, so it will be simply this. So the correct option here, if you see, it's the A option. Now see, you can easily calculate this through by seeing it at the slope also. The slope for Y is this at any point, and the slope for X is this, right? Now if you see the slope of Y is less than the slope of x. Sorry, the slope of y is greater than the slope of x. If you look at here, slope of y, it is greater than the slope of x. What does that mean? What is the slope? Slope is dt by dt, because this is capital T, this is small t. Change in temperature with respect to time of y is greater than the x. What this means? If the rate of change of temperature of y is greater, that means the rate of heat loss by y is greater. So that would simply mean that emissivity of y is greater than. So you can follow either of the methods and you can find out the solution. So now let's look at this question. In which of the following phenomenon heat convection does not take place? We are asking, it's not taking place. So this is a theoretical question. So let's look how to solve this. Now, land and sea bridges. I hope you know what is land and sea bridges. Let me explain this. So this may even come in the mains exam. This was a part of JEE question. Now what happens that the land undergoes heating faster and sea, it heats slowly because of its high specific heat. Right, it has a specific heat of 4200, very high compared to the land. So the land gets heated up faster. What happens when it gets heated up? The air that is in contact with it, it will rise up, air molecules, because they become lighter. And here there is more air. Here the air is going up, here there is more air, that is the colder air. So what happens that there is a pressure difference. There is high pressure here, there is low pressure here. So the air flows like this. That is called the land bridge. What happens in sea bridges? During the night, what happens? The land cools faster. Again, because of the same phenomena, and the sea cools slowly because of high specific heat. So then in that case, the air follows the opposite direction. Now what is happening here is that these air molecules, they are getting heated up and they move up. So it's the actual movement of the air molecules upward. So that's what makes convection. So this is a convection. Now boiling of water. If you are boiling of water, there is a burner. What happens? The water that is in contact here, it goes up. That is a heated one. And the colder water comes down. Now this colder water again gets heated up. This goes up. So again there is a movement of water. Actual water molecules are moving. So boiling of water is also a convection process. Then there is air around the furnace. Air around the furnace means, if you have a furnace here like this, air that is surrounding it, it will get heated up and the air goes up. Right? Similarly, this heated air that is going up will cause the other air molecules to come down. These again get heated up and they again move upwards. So again there is actual movement of the water molecules. So this is again convection. Heating of glass surface due to filament. Obviously this should be the correct option because we have eliminated all the three. Let's see what is happening here. What is happening, you may have observed that as soon as you connect a bulb, it suddenly gets heated up. Now since it is filled with an inert gas, there is a very less chance of conduction. So this heating is actually happening through a different process called the radiation. The radiation emitted from here, it reaches this surface and it heats it up. That is responsible for this rise in temperature. So this is the process where convection is not taking place, rather it is the radiation. I hope you have understood all of the processes and you will be able to solve all the questions that come either in the IIT-JEE or various examinations based on the theory and the questions that we have solved even in between and these IIT-JEE questions.
Having gone through our video lectures and video solutions may have cleared most of your doubts. For any further doubts, you may visit our site www.askIITians.com. On the site, you will find a tab called Ask a Question. Click on that tab. Clicking on the tab will take you to the next page where you will find an icon Ask Experts. If you want to ask any questions, you can select the category of the questions. Like if you want to ask question from suppose wave motion, click on that option wave motion, paste your doubts here. If you want to attach some image of the question, you can attach the image also. Your question will be answered within 24 hours to 48 hours.
So we have seen how to apply the concepts that we have studied in the thermal properties of matter in solving the questions that were based and asked in IIT-JEE. Now we saw that we have studied what exactly is heat, the temperature, the modes of conduction of the heat like the conduction, convection and the radiation. Then we saw the laws that were based on it like the Stephen-Boltzmann law, the Wien's displacement law, we had the Kirchhoff's law, and then we also had the Newton's rate of cooling. And we applied all these concepts and we saw how we can easily solve the questions that were asked in IIT-JEE. Now, for more of the lectures on chemistry, biology and mathematics, stay tuned to askIITians.com. Thank you.